All right, so yesterday we solved square root equations. Today we're gonna take a look at what their graphs look like. So we're definitely gonna be using Desmos. So open up a Desmos tab and follow along as we go through these different graphs. So over on the left side of the screen, I'm gonna try to put the graph there and the equations that I've already typed into Desmos. And then of course we'll graph it in Desmos and see what it looks like. So let me spread this out just a little bit more and we'll be ready. All right, so A tells us to do f of x equals the square root of x. So I've already typed that in, and that's this purple graph that's right here. So I'm going to do a little sketch on my paper, something along those lines. So this is what we will call our parent function. So this is what I would call the parent function. I call it the parent function because it's the one that starts everything else off. So it's the most basic one. It's centered at the origin. It's only in the first quadrant. As I move on and do different examples, we can make it move and shift and do different things like that. But for right now, this is the most basic one that is starting at the origin. And it's the purple one that's over here in Desmos. Okay. B, I've already typed that in as well. The square root of x plus 2. So let's see what that looks like. So I'm going to get rid of this one. Okay. So it looks like this one is starting at 2. Still has the same arch that the first one did, but it moved up on the y-axis. So that is what the second one looks like. The third one, f of x equals x minus 2. So that would be this one right here. So this is my origin at 0. Looks like I'm starting at positive 2 on the x-axis. So it goes that way. C. There's C. I already typed this in as well. If I highlight that one, it looks like it did a flip across the x-axis. So I've done a rough sketch of what all 4 of these look like, and we use Desmos to help us out. Now I'm going to fill in some different characteristics that we should notice about the graph. So one thing that I'm going to do before I fill out the note sheets, let me highlight the first graph. This is my parent graph. So this is the one that's going to start everything off. If I highlight number 2, notice from the purple to the black, my graph moved up 2. So from the purple to the black, the whole entire function moved up 2 because I have this plus 2 that's on the outside. So it moved my function up 2 spaces. Now, if I come down here, I have one that has the square root of x minus 3. So notice from the purple to the green one that just popped up in Desmos, that function moved down 3 spaces. So if you have a number on the outside and it's positive, it's going to move it up. If you have a number on the outside and it's negative, it's going to move it down. So that's one thing that we should be able to do, one transformation that we should be able to discover. Now let me get rid of this one. Let's take a look at the square root of x minus 2. Notice the positioning of the 2. The negative 2 is inside of the square root. Notice from the purple to the red graph over here in Desmos, it moved to the right 2 spaces. And I'm going to come down here and highlight this one. So it's the second purple one that popped up. This one right here. Notice this graph right here moved left 3 spaces. So the number on the inside of your function, if that number is negative, it's going to move it to the right. If that number is positive, it's going to move it to the left. So we're just trying to discover what effect it has on our graph as we change the numbers in our graph. And the last thing I want to talk about, if I have this one here, notice from the purple to the blue, my graph flipped over the x-axis. So another word for flip, I can say it's a reflection across the x-axis. So from the purple to the blue one here, the purple one is our parent function, and then it flipped over the x-axis. So let's write those out in words. So we're going to take a little bit of notes here. So let's write that out. And I'm going to try to put this all in the same screen. All right, there we go. So the graph of f of x equals the square root of x plus k is a transformation of the graph f of x equals x. If the number on the outside is positive, the graph moves up. If the number on the outside is negative, the graph moves down. And particularly the kind of transformation it is, it's a slide transformation. It'll either slide it up or slide it down. The second section, the graph of f of x equals x plus h. Notice the positioning, the h is inside. This is still a transformation, and I'm going to abbreviate. It's still a transformation. If the number on the inside is positive, it's going to move it to the left. If the number on the inside is negative, it's going to move it to the right. And particularly, this is a slide. The graph of f of x equals negative square root of x is also a transformation, and I'm abbreviating. And what it does, it'll flip it over the x-axis. And this one more particularly is a reflection. So flip reflection over the x-axis. So I'm going to do the first 4 graphs that we did. The first one was a parent function, but the other 3 I'm going to go back and label what effects that we had from the parent graph to the function that we typed into Desmos. So from my parent function to b, my graph moved up 2 spaces. So this number on the outside of your square root caused it to move up 2 spaces. Now, if I compare that to c, so from my parent function over here to c, I had an x minus 2 inside of the square root. This moved the graph right 2 spaces. So this one was right 2 spaces. And I can see that in my graph right here. The parent function starts at the origin. This one moved right 2 spaces. And the last one, from my parent function to this one down here, if you have a negative in the front, it reflects it over the x-axis. So this is a reflection over the x-axis. Now we're going to try some examples. So I think I'm done with Desmos for the minute. I might go back to it. So let's try some examples. So this is what we've discovered so far. We got our parent function, and we've gone through. We figured out how to move it up or down. That's the number on the outside. How to move it left or right. That's the number on the inside. And if I add a negative in the front, it's going to reflect it over the x-axis. And these are all those transformations that I just verbally said written out. So we're going to try some examples down here. Okay. Example A. The graph of f of x equals the square root of x is translated 5 units to the right and down 3. So I'm starting with my parent function. I want to make it go right 5 spaces. So the number on the inside is what moves it left or right, and it's the opposite of what you think. So if I'm moving it right 5 spaces, it's actually going to be x minus 5, the square root of x minus 5. And if I want to go down 3 spaces, I would add a minus 3 on the outside. So this negative 5 inside the square root symbol moves it right, and this minus 3 on the outside moves it down. Let's try this one. The graph of f of x equals the square root of x is reflected over the x-axis and translated up 2 units. So let's see what that looks like. If you want to reflect over the x-axis, that's right here where my pen is at, you add a negative in the front. So I'm going to add a negative in front of my square root. And if I want to move it up 2 spaces, the number outside of the square root moves it up or down. So if I want to move it up 2 spaces, there we have it. And for C, the graph of f of x equals the square root of x reflected over the x-axis, translated down 3 and left 1. So we need to consider all of these options. First, if I reflect it over the x-axis, that means I need to add a negative in front of the square root. If I want to translate it down 3, there's going to be something on the outside of the square root. So I'm going to leave a little space, and I know that minus 3 is going to go on the outside of the square root. And last but not least, I want to go left 1. That means that number needs to be inside of the square root, and it's the opposite of what you think, and it's a positive there. And it does say sketch each graph, so of course you can use Desmos. You would type that in, and you can do a little sketch down here at the bottom. But these are our transformations for our functions. It helps us figure out how to move it up, down, left, right, or reflect it over the x-axis.